Hi everyone, I'm going to be going over the sine and circular motion quiz review. The front is a no calculator section, so um, it's fine to use a calculator to check your work, but these are the kinds of questions you could have on the quiz that you would not have a calculator for. And then the back is the calculator section where you are allowed to use a calculator if you need it. So for number one, we need to determine if the sine value is positive, negative, or zero at these four angles. So first I want to kind of recap what sine is. So sine of any angle that we plug in. What you remember from geometry, what we reviewed in class, is that sine is the opposite over the hypotenuse. So it's the ratio of the opposite side in a triangle, the side that's opposite the angle theta, divided by the hypotenuse. Now, again, just to be clear, this symbol is theta. That's how you say it. It's just a Greek letter, but it's what we use to represent angles. It's just another variable. Instead of using x, we use theta. So sine of any angle is equal to the ratio of the side across from it, or the opposite side, to the hypotenuse. Now, when we're looking at circles and the angles in a circle, we can kind of rethink about sine in a slightly different way. Since we're always looking at angles inside the circle, we're always the opposite side from the angle inside a circle at any point. For example, if this is my angle, theta, this is my opposite side, we can also call this the height from the center. And then this hypotenuse is always the radius of the circle. So when you're working with sine in all these questions where we're using a circle, we can just think of sine of theta as the ratio of the height of a point on the circle. The height, it is away from the middle, and the ratio of the height to the radius, because the hypotenuse of any triangle in this circle is always the radius of the circle. So just think of sine as those things. Instead of thinking about the opposite over hypotenuse in the context of a circle, we can just think of it as the height divided by the radius. So all we have to do is determine if the sine value is positive, negative, or zero. So I want to start by showing on the circle when is sine positive, when is sine zero, and when is sine negative. So first of all, whenever I make a triangle where the point is above this is what we call the midline. Whenever I make a triangle that goes up, the height is positive. So my radius is always positive, because no matter where I go in the circle, I'm going to have a positive radius. So the sine value is positive whenever the height is positive, or in other words, whenever the point you're looking at on the circle is above the midline. So sine is positive for any angle above the midline, because that's where the height is positive. So sine is positive. Now, any point below is going to be negative, because here our height is going down. Our height from the center is negative, or the height from the midline is negative. So since the radius is always positive and the height is negative below the midline, our sine ratio is also going to be negative below the midline. So sine is negative. Now, sine is zero. I'm going to erase this real quick. Sine is zero if it's positive above the midline and negative below the midline, then sine must be zero at the midline. So this is where, at the midline, that's where sine is zero. This is because any point that's on the midline, like here or here, those points have no height. I can't make a triangle with those points. They're on the midline, so the height from the midline is zero. And if the height is zero, even though the radius is still the same, 0 divided by anything is 0. So if the height is 0, the sine ratio is 0. So again, you can kind of see already how sine is determined by the height of a point from the center or from the midline. So if we have a point above the midline, the height is positive, so sine is positive. If we have a point below the midline, the height is negative, so sine is negative. If we have a point on the midline, the height is 0, therefore sine is 0. So if we start by looking at 545 degrees, I'm actually going to first mark all the important degrees on the circle that we should know by now. So we know that this is 0 degrees, this is 90 degrees, this is 180 degrees. I'm going to try and put the degree symbol in, it might be messy. And then down here we have 270 degrees. And then of course, when we get back around, we have 360 degrees because that's the total degrees in a circle. So if I'm looking for 545 degrees, I'm going to have to go past 360. So I need to figure out, well, if I go 90 degrees past 360, that's 360 plus 90, which gives us 450. So this is also 450 degrees if you keep going. And then that's still not quite to 545. So if I add 90 to that, I would get 540. And that's as much as I need because 545 is going to be just a little bit past 540. That's 545. So whenever you have an angle that's bigger than 360, just keep adding 90 degrees to 360 until you get to a number that's close to what you're looking for. So 545 degrees, it's a little past 180, so it's below the midline, which means it's going to have a negative sine value. All right, let's do 312. So 312 degrees, that's between 270 and 360. It's about here. So that's 312 degrees. So again, that's below the midline, so it's going to have a negative sine value. Sine of 27 degrees. 27 degrees is between 0 and 90, right around here. So since this is above the midline, the height is positive, so sine is positive. And then lastly, sine of 0. Well, 0 is right here. It's right on the midline, which means the height from the midline is 0. So this value of sine has to be 0. So those aren't too bad. You really just have to plot the angles on the circle, see if they're above the midline, below the midline, or on the midline. That tells you whether sine is positive, negative, or 0. All right. Number 2, we need to fill in the blank with less than, greater than, or equal to sign based on the sine value of each angle. So again, it really helps to just start by always label your important angles. 0, 90, 180, 270. These are all degrees. And then, of course, 360. So start by plotting 190 and 290. So 190 is going to be about 10 degrees past 180. Not about, it's exactly 10 degrees past 180. That's 190. And then 290 is 20 degrees past 270. So these are just rough estimates of where it would be. It's pretty obvious these are not at these points are not at like the same height at all. So these are definitely not equal. Now I know that sine is negative below the midline. So they're both going to be negative sine values. But which one has a smaller negative height? That's going to be 190. But think about negative numbers. If the lowest sine value I can have is -1, which is down here at 270. And then again, the highest sine value I can have is 1 up here at 90. And in the middle, I have sine can be 0, sine is 0, midline. So thinking about like a number line, if your number line goes from -1 to 0 to 1. The smaller value is the more negative value. So the angle that is closer to -1 or has a bigger negative height is the smaller value on a number line. And the angle that's closer to 0 is going to be bigger. So again, I'm just saying with negative numbers, I'll draw a number line, -1, 0. With negative numbers, the closer I get to -1, the lower my value is. The closer I get to 0, the bigger my value is. So since 190 is closer to 0, that means it has a bigger value than sine of 290. Because sine of 290 is going to be closer to -1 since it's a bigger negative height. You can also kind of just think of it as the closer the point is going up, like 190 is a higher point than 270. So it's going to be a bigger sine value. It's really just that simple. Let's do another one so I can kind of show that again. So sine of 280 and sine of 350. So sine of 280, let's see, 280 is a little past 270. Sorry, here we go, 280. And then 350 is a little before 360. So again, I just really need to look at which angle is at a higher point. That's going to be my bigger sine value. And my angle that's at a lower point is going to be my lower sine value. So 350 is higher up, so sine of 350 is bigger than sine of 280. But you really can't. Some people I think are going to try and do this. Oh, 350 is bigger than 280. Boom. Nope, that doesn't work because look, here 190 is actually higher up on the circle. So that's our bigger sine value, even though 290 is a bigger number. So you can't rely on it that way. You really have to draw it on the circle. All right, sine of 30 and sine of 50. So 30 is like right here. 50 is a little farther. So which one's higher? 50 degrees is higher up. So the sine value of 50 degrees is bigger. And then last one, sine of 45 and 179. Well, 45 is between these two. 45. And then 179 is almost to 180. So 45 degrees is higher at a higher point than 179. So sine of 45 is going to be bigger than sine of 179. Great. Next one, fill in the blank with the correct sine value. I kind of mentioned this in the last video, but again, if you fill in your important angle values, these are not the kind of values you need a calculator for. Sine of 270 is the absolute lowest point. So it's the lowest possible value of sine you could have. And the minimum value of sine you can have is -1. So another way to think about this is, since we know sine is the ratio of the height to the radius, if you look here at 270 degrees, my height from the center is the radius, but it's negative because it's going down. So if my height and the radius are the same, the ratio is 1. And then since it's going down, I know it's negative, so it's -1. Sine of 360, I always forget to mark that one. 360 is over here. So since we're on the midline, the height is 0, so the sine value is 0. And then lastly, at 90 degrees, is similar to 270. The height and the radius are the same, so the ratio of those is 1. Since it's going up, it's +1. You can kind of just make sure you remember all of these. And the only other angle you could be asked to find the exact value of here would be 180. And here, sine of 180 degrees is also equal to 0. So those are the ones that you should know the exact value of. It's either 1, 0, or -1. Otherwise, like sine of 45 degrees, you don't need to know what that is. That's something you would have a calculator for. These are the kinds of values you can do without a calculator, and you should know how to do without a calculator. All right, number 4. So for each sine value, determine two other angles that would have the same sine value. One angle must be less than 360. All right. Let's start with, okay, 200. So again, on my circle, I need to find where 200 is. So if I know this is 0, 90, 180, and 270. 200 degrees is past 180. Let's say here. So 200 is there. So since one of the angles has to be less than 360, that's saying you need to have at least one other angle within that first rotation that has the same sine value. So since all of the angles in my circle are going to have the same radius, I'm looking for which angles have the same height. Same height means same sine. It's a good saying to have in your head. Same height means same sine. So I need to find the angle that is across from it so they have the same height. Okay, so the way I'm going to do that is, once again, I know this is 200. So 200 is, this looks like a 20, my bad. 200. Okay, so if that's 200 degrees, I'm trying to find the one across from it. The easiest way to do that is to find out how far is 200 from 180. Well, 200 is 20 degrees from 180. So therefore, if I find the angle that is 20 degrees from, this is 360, we'll just call it 360 instead of 0 for now. If I find the angle that's 20 degrees below 360, that'll be at the same height. So to get an angle that's 20 degrees below 360, I can do 360 minus 20. That gives me 340. So that means one of my angles is 340 degrees. So looks like 9. All right. Now, that's the one that's less, that one's less than 360. So now for my second one, I can make it really easy. If I know that 200 is one of my angles and I want to find another angle that's going to end up at the same spot, I just need to go one more full rotation around the circle. So 200 plus one more full rotation, that's 360. So I just need to do 200 plus 360. That gives me 560. So 560 degrees is another angle, but that one's bigger than 360, but I'm allowed to have one that's bigger. So that one's good. So you can always find one of your angles by just adding 360 to, you could have also added 360 to 340 if you wanted to. It would still it wouldn't give you the same answer, but it will give you an answer that is still correct. All right, so sine of 167, all right. 167 is before 180, so it's going to be like here. I'm not going to keep marking all of the 0, 90, and 180 and 270, but you should know that. 167 is here, and I need to find an angle that's the same height, so it needs to be right across from this over here. So the way to figure out what this angle should be is I really need to know how far is 167 from 180. Well, 167, if I do the math, 180 minus 167 is 13. So I'm just going to draw an arrow. This is 13 degrees. So if that's 13 degrees above 180, then my angle from 0 that would match that is 13 degrees. It's kind of like adding 0 plus 13. You don't really need to do that though. You just know if it's 13 degrees before 180, then the one at the same height is 13 degrees above 0. So 13 is one of my answers. Now to get the other really easy one, I just need to add 360. Now I'm going to show you an example here. I can add 360 to I can add 360 and 13 as well. So that gives me 373. So you could have added it to 167, but you can also add it to 13. Again, you won't get the same number, but you still get an angle that answers the question. All right, 59 degrees, that's in my first quadrant. It's between 0 and 90. 59. So to find the angle at the same height, I'm going to be over in quadrant 2 because they have the same height. And if my angle 59 degrees, that's 59 from 0. I need to find the angle that's 59 from 180. So in this case, it's 59 degrees before 180. So I need to take 180 minus 59. And that gives me 121. So 121 degrees is one of my angles. And then again, to get the second angle, I just need to add 360 to either 59 or 121. I'm going to add 360 plus 59. That gives me 419. This is the kind of math you do need to be able to do with a calculator for sure. This is on the no calculator section. So 300 degrees is the last one. So 300 degrees, that's between 270 and 360. So 300 down here. And first I need to find one that is within the circle. So the one with the angle with the same height is going to be over in quadrant 3. So to do this, I need to figure out how far is 360 from, or how far is 300 from 360? That's 60 degrees. So this angle I'm looking for is 60 degrees from 180. So since it's below 180, past 180, I'm going to do 180 plus 60, which gives me 240. And then to get my last one, I can just take 300 or 240 and add 360. I'm going to take 300 and add 360. That gives me 660. And that's it. So as you can see, kind of what we're doing every time, you find your angle that is given, draw the angle that you're looking for, and then you're always looking for, as you can see, like how, let me use a different color, how far is the angle you have from the midline. That's kind of what you're always looking at. How far is it from the midline, and then figure out if you need to like add that to 180, subtract it from 180, add it to 360, or add it to 0. Like there's really not a trick for this because you really have to draw it and think about, is it before 180, after 180, or before, right, a little bit before 360, or is it a little after 0? You have to look at that to figure out what math you need to do. Number 5, this is the last one on the non-calculator section. This is a Ferris wheel question where you have to estimate the height. Don't stress about this. Well, you need to be able to do this for the quiz, but some of you might be like, oh, your estimate was like a couple feet off from mine, or like 5 feet from mine. Well, it's estimating. So like you're guessing. It just has to be within a certain range. So that's fine as long as your estimation makes sense and you can explain it. If there was a question like this on a quiz, it would be multiple choice. So you wouldn't be like just coming up with something in your head. You'd be picking like one of the solutions that makes the most sense. There's not, there wouldn't be any ones that would like both make sense. So there would only be one correct answer in that case. But for this, it's okay if your answer is a little different from mine, as long as it's within the range of values. So let's start by labeling the Ferris wheel. So if the center is 100 feet from the ground, so this is 100 feet, and the radius is 65 feet. Estimate the height at each angle measure. All right, well, I'm going to start by labeling all my angles. This is 0, 90, 180, 270, 360. So at 110 degrees, let me find that. 110 is past 90, but before 180. How high could the rider be? Well, it would help if I find the height first. What's the highest height they could be at? It would help to find the height at 180 and at 90 first. So the height at 180 is going to be the same as the height of the center from the ground, which is 100. So the height at 180 is 100 feet also. as well as over here at 100 feet. They're all 100 feet because they're all the same height from the center. They're all the same height as the center. At 90 degrees, our height is the 100 feet plus the length of the blade, or the radius of the Ferris wheel. So the radius of the Ferris wheel is 65. So to get the height at 90, so height at 90 degrees, I'm going to add 100 plus 65. In case you haven't noticed, to get the height at the highest point on the circle, you're always adding that height from the center and adding it to the radius. You're always adding those two numbers together to get this. So the height is 165 feet. And then we already said the height at 180 is 100 feet. So at 110 degrees, it's going to be between 100 feet and 165 feet. But it's going to be closer to 165 because 110 is closer to 90 than 180. So I'm going to pick like 155 feet. Again, it's okay if yours is a little different. But I'm basically just going off the fact that I know it's close to 165, but it's a bit farther away from 165 and it can't be less than 100. So I would say anything between 100 and 165, but closer to 165 would be a reasonable estimate. All right. At 350 degrees, that would be here, 350. So for this, it's going to be between the lowest height and then the height at 360. So it would help to find the height at the bottom of the Ferris wheel. To find the height of the bottom from the ground, you have to take the height of the center, which is 100, and subtract the radius. So the height at 270, you just take 100 and subtract 65. That gives you 35 feet. So that's the height here down at the bottom. And then we already know the height at 360 is 100. Because it's the same as the height as the center. The height of the center. So 350 is between 35 and 100 feet. But as you can see, it's closer to 100 feet. So I'm picking like 95 feet because it's close to 100, but it's definitely not less than 35. It should be closer to 100 though. Great. At 225 degrees, let's see, 225 degrees is like kind of halfway between 180 and 270 as far as the angles go. And I already know that the height at 180 is 100 feet and the height at the very bottom is 35. So it's got to be between 35 and 100. It's towards the middle maybe. So I'm the middle of 35 and 100. So I'm going to pick like 60 feet. Really anything between 35 and 100 is fine as long as it's somewhere in the middle. So again, this is not like super, like you don't have to have the same exact numbers as me as long as you understand how to get the estimate and that you could explain it. Sometimes we ask you to explain things on quizzes, so you need to be able to explain that. And yeah, as long as it's in that range and you understood everything, you're fine, even if your numbers aren't the same as mine. Don't feel like you have to change them. All right. Going to the calculator section. So just forewarning, just because it's the calculator section doesn't mean you need a calculator for every question. There are actually a lot of questions on here that you don't really need a calculator for. And the same will go on the quiz. The calculator section doesn't mean you need to be using a calculator for every question. So if you feel like, oh, I didn't really need a calculator for some of this, that's fine. That doesn't mean you did it wrong. So don't worry about that. So Amanda's riding a Ferris wheel that rotates counterclockwise, has a center that is 80 feet from the ground. The radius is 28 feet and it takes 40 seconds to complete a full rotation. That just made me think if, yeah, in this last problem, I just want to make sure we could tell what the important information was. So 80 feet off the ground, that means my center here is 80 feet from the ground. Some people are drawing this height part and stopping here. That's not correct. We're talking about the height from the very ground, the very bottom to the center. That's 80 feet. The height or the radius is 28 feet. So that's this blue line here. Okay, so it takes 40 seconds to complete a full rotation. All right, how many degrees does the Ferris wheel rotate each second? So if I know that it takes 40 seconds to go a full rotation is telling me 360 degrees. Always, that's always a full rotation. So to find out the degrees each second, that's degrees per second. So I take the total number of degrees, 360, divide it by how long it takes her to get around, which is 40 seconds. If I divide those, I get 9 degrees per second. You may or may not need a calculator for that, depending on how your mental math skills are. Okay, so 9 degrees per second. You just take the total degrees, which is always 360, divide it by the amount of seconds it takes, 40 seconds. Write a function which could be used to determine her height off the ground at any time t. So I'm writing a function of height based on time. So I'm going to call it h of t, like instead of f of x, h of t. So I know that my function always starts with the radius, which is 28, times the sine of an angle. So normally when we're writing an angle, we put theta in here, but we're trying to write a function based on time, not on an angle. So we know what goes inside of sine needs to be an angle. So if we're given a time, like say it said like how far is, or how many degrees has she gone in 5 seconds? Well, if I know the degrees she goes each second, like 9, so 9 degrees per second. And if I know she's going for 5 seconds, 9 degrees every second, that's 9 times 5. So she'd be going 45 degrees per second. That's not what the question's asking. I'm just giving you an example. If I have degrees per second and I'm given a number of seconds, then I have to multiply them to find out how many degrees she goes. So she would have gone 45 degrees in 9 seconds. Or, sorry, 45 degrees in 5 seconds, because it's 9 degrees per second times the amount of seconds. So we're always taking that degrees per second and multiplying it by the time. So inside the parentheses, we have 9t. So it's always the degrees per second that you need to find times t. That's what gives you an angle inside of sine. You can't just put t inside of sine and not multiply by the degrees per second, because you can't plug a time into sine. You have to plug in an angle. The only way to get an angle from the time is to multiply the time by the 9 degrees per second. And the last part of our function is always to add the height from the center, which is 80. The height of the center from the ground. So it's really like the functions we've been writing. It's just a little different because inside the sine, we need to have the degrees per second times t. Now, how high off the ground will she be after 17 seconds? To do this, I just need to plug in 17 into the function I just wrote. So we're plugging 17 in. So we have 28 sine of 9 times 17 plus 80. This is an example where you want a calculator. I plugged in 17, so I'm going to use my calculator so you can make sure you know how to plug this into a calculator. Sorry. All right. So if I plug this into my calculator, 28 sine 9. Ooh, I almost forgot. I need to make sure I'm in degree mode. Let me go to my mode. Degree. All right, now I'm good. If you get like a really weird negative number when you do this, that's your problem. You need to make sure you're in degree mode. And then plus 80. That gives me 92.7, so I'm going to round that to 93. 93 feet. Now, how high off the ground will she be after 27 seconds? So similar thing. We're using the same exact function. I'm plugging in 27. So I have 28 sine of 27, 9 times 27. Can't forget that 9 times part. So what I just plugged in was 27 for t. So if I put that in my calculator, I'll show you that. 28 sine of 9 times 27 plus 80. So you get 55. I'm going to round to 55. Right. Those are really just calculating questions. All right. This is some more thinking. So I'm going to mark again. This was 28 feet. This was 80 feet. Right. At what time will she reach the top? All right, so if we remember, it said it takes 40 seconds to go all the way around. All right, so I can do some quick math here. So if it takes 40 seconds to go all the way, so 40 seconds to go all the way around, then to get halfway around, it's going to take 20 seconds. So to get a quarter of the way around, it's going to take 10 seconds. You can also think of that as 40 divided by 4 because she gets to the top of the Ferris wheel a quarter of the way around, and 1/4 of 40, or 40 divided by 4 is 10. So at what time? It will be 10 seconds. How high off the ground will she be when she's at the top? Well, to find that, I just need to take my height of the center, which is 80, and add my radius. So 80 plus 28, that gives me 108. So she'll be 108 feet off the ground. This is an example of some questions that you really don't need a calculator for. At what time will she reach the bottom? Okay, well, if it takes 10 to go quarter, 20 to go half, and then 30 to go one more quarter, or it's 10 more seconds to go another quarter, that's going to be 30 here. So it takes 30 seconds to reach the bottom. How high off the ground will she be when she's at the bottom? Well, to do that, you need to take the height of the center and subtract the radius to get this height down here. So I take that height from this of the center, which is 80, and subtract the radius, which is 28. So 80 minus 28, that gives me 52. So 52 feet. Again, all these questions asking about the height, like sometimes you really don't need to use sine. Like these are examples where it's just, oh, it's the height of the center plus the radius, or the height of the center minus the radius to get the lowest height. So don't overthink those. Lastly, between what two times is she more than 80 feet off the ground? Okay, well, 80 feet is the midline. So whenever she's above the midline, oh wait, the first one's less than 80 feet. Okay, so if 80 feet is the midline, then I'm wondering what time she's going to be below the midline. So I know that she hits the midline at 20, and then she comes back around at 40. So from 20 to 40, she's less than 80 feet because she's below the midline. 20 to 40 seconds. Remember, here it's asking about time, so we're talking about seconds. We're not talking about degrees. All right, and then when is she more than 80 feet? That's going to be from when we're at 0 seconds to when we're at 20 seconds. It's the other half of the time. So when she starts at 0, and then she's above the midline until 20 seconds. That's when she goes below, so from 0 to 20. All right, yeah, so all those questions, as you can see, we really didn't need a calculator for. So there might be questions like this on the calculator section. Doesn't mean you need to be using a calculator using sine and stuff like that. It's really just kind of using what you know about time and height and measurements. It's really not even using a whole lot of new stuff. All right, so let me know if you have any questions. I hope this helped, and good luck.